Greetings, everyone. This is Rick Balkin at the School of Education in the University of Mississippi, Educational Research and Design. We're going to be talking about how to determine your sample size. And we'll review a coffee in this first episode of Quantitatively Caffeinated. So let's get started. Very often, we know what type of study we want to do. We know what analysis we want to do. We're just not sure about how big our sample size needs to be. And there's a free tool out there that can help us with that, and it's called G-Power. I'm going to share my screen with you and take you to this website. And the website is really out of Dusseldorf, Germany. If you just click on Google and type in G-Power, this will be the first website that pops up, and you can download this program for free, whether it's for Mac or Windows. And I recommend that you do it. It's really easy to help you make decisions about your study. Once you have G-Power, you can, start using it to determine your sample size. So let me show you how that might work. This is G-Power, and you can see that G-Power will run a different variety of tests: chi-square tests, F-tests, T-tests. We're going to work with F-tests. And let's just start off with something simple, like a one-way ANOVA. You can see that we can do a factorial ANOVA. You can do repeated measures ANOVA. You can do repeated measures with a between subjects effect. Let's just do a one-way ANOVA. It's simple. And so if I want to determine my sample size, it's going to give me a few different options. It's going to say, do you want to do an a priori power analysis? And that is the analysis we use to determine our required sample size. There's a number of other tests which you can read about in the manual. The ones I tend to use are the a priori power analysis and the sensitivity power analysis, which I'll talk about at a later time. Let's focus on this a priori power analysis. So one thing that G-Power is going to do is going to set up some defaults. The first default it sets up is the effect size default. And you can see that it uses Cohen's conventions for effect size. For Cohen's F, it's already set as a default for a medium effect size, but you can change that. You can change that to 0.10, 0.40. You can change it to any value you want, but those are the suggested conventions. The other default it has is that it sets your alpha level at 0.05. Now, a third default it has is it sets your power at 0.95, which is really high. That's saying that there's only like a 95% chance of finding statistical significance if it actually exists, and that there's a 5% chance of making a type 2 error, consistent with our likelihood of making a type 1 error. But Cohen actually recommended a lower threshold for social and behavioral sciences. He recommended 0.80, basically because at 0.80, it lowers your required sample size so that you can actually get some research done. He basically found that a 0.95 threshold for power was unrealistic. And I'll show you why in a little bit. And then the number of groups. Let's just say I'm going to look at SCS, low, middle, high. And so I'm going to put in 3 groups here. Now, with these conventions in place, I just click on calculate, and it says I would need 159 in my sample in order to find statistical significance for a moderate effect. Now, notice a few things. What if I don't need to find, I have a statistical test that's sensitive? What if I want to be able to find statistical significance only for a large effect? Well, in that case, my sample size drops to 66. But very often we are interested in finding statistical significance for a medium effect. And so I like that convention. If you want your test to be even more sensitive, and find statistical significance when your effect size is small, obviously you'll need a much larger sample size of 969. So again, I like that convention of a moderate effect size. What if we followed Cohn's or didn't follow Cohn's guidelines and used the default offered in G power of 0.95? You can see then I need a sample size of 252, so substantially larger. So I like this convention, and I recommend this convention of 0.80, 0.05, and a moderate effect at 0.25. And so, notice what happens if I have more than 3 groups. If I have more than 3 groups, let's say I have 4 groups, my sample size required increases. And so these elements do influence the sample size. Now, if I had to roll the dice for like dissertation research or something, I would bet you're probably not going to run a one-way ANOVA. You might, but you might want to do something like a multiple regression. And that's an option here too. You can do a linear multiple regression. Obviously a variety of tests. And in this case, the effect size is no longer F, but they're using F squared. And if you look at the conventions for F squared, they're a little different than, well, they're a lot different than what was used for just Cohen's F. For F squared, the conventions are 0.02, 0.15, and I think 0.36. Whoops, almost had it up on the screen for you. So, but it'll usually if it behaves, it'll post for you. So, but same thing here. I want to put 0.80, change that, keep this at 0.05, have my moderate effect size default. There it is, 0.35. I said 0.36, but it's 0.02, 0.15, and 0.35. Now, keep in mind, this is not R squared. R squared would be something like 0.02, 0.13, and 0.26. So there's an effect size conversion that you can do. But this is the effect size conventions for small, medium, and large for running an a priori power analysis. And let's just say I had 5 predictors. If I have 5 predictors, I'll need a sample size of 92. If I only have 2 predictors, I'll need a sample size of 68. So the more predictors I have, the less sample size I need. The more predictors I put in the model, the larger the sample size is required. And so this is a good system of trying to determine more empirically based how big my sample size needs to be. And I understand that there's some anxiety with this process, and whenever I have a problem with anxiety, I like to have a cup of coffee, and I do recommend this HEB coffee. It's a medium roast called Texas Pecan. You can't get it here in Mississippi. Let me quit sharing my screen here so you can see this. Yeah, so Texas Pecan. You won't get this in Mississippi, but you can probably order online from HEB, which is a Texas grocery store chain. I just made a cup of this, and it is delicious. So anyway, I highly recommend Texas Pecan. Not real sweet, a little bitter. Tastes great with some milk. Yeah. All right, folks. So hope you enjoyed our episode of Quantitatively Caffeinated. If you need to reach out to me, I'm at edres@olemiss.edu. See ya.